So it's time to look at another complicated question. Oh yeah, complicated. Here we go. Nice linear question for you. We're going to do the reciprocal of this. But again, what you have to remember is always graph the original. So if you look at this, this says y equals to minus a half x plus 4. There's your wonderful intercept at 4. So 1, 2, 3, 4. There's our intercept. We know that this is a rise here of -1 and a run of 2. So down 1 over 2. Now we can keep going down 1 over 2, down 1 over 2, down 1 over 2, and figure out your x-intercept that way. But that doesn't necessarily always give you the nicest answer in the world. What you should do is remember that an x-intercept happens when y equals to 0. And just solve it. It's so much nicer than going on and on and on because, well, this case, it just happened to hit the x-axis perfectly. It may not necessarily do that every single time. So, okay, 0 equals to minus a half x plus 4. Bring the -4 over to each side, and look what you got. This is kind of neat. This cancels out, right? Giving you -4 equals to minus a half x. To get rid of the minus a half, just multiply both sides by -2. Look at this. So you end up getting 8 equals to x, because minus a half and -2 cancel. So x equals to 8. So in fact, 1, 2, 3, 4, 5, 6, 7, 8. Oh my goodness, look, it's right there. Now, the cool thing about this is that you're going to end up reciprocating this. 1 over 1/2 x, negative 1/2 x, plus 4. Now, check this out. You already made this equation equal to 0. So guess what? It's 0 at x equals to 8. Well, wait a second. Isn't that considered to be a critical point? Well, no kidding. Because if you let this, negative 1/2 x plus 4 equals to 0, we know that x already equals to 8, which is, guess what? A non-permissible value. Look how valuable that is. Just by going out and figuring out how to graph it, it gives you so much information. So if that's a non-permissible value, guess what else we can do with it? Yep, vertical asymptote. X equals to 8. There we go. Our vertical asymptote goes right smack through there. So now we can draw the original graph. The original graph basically goes something like that. Okay? Something like that. Beautifully. If I was any straighter, oh, I'd give up coffee. Yeah, right. Now, the cool thing is, here's another couple things we have to do. I want to figure out the invariant points for a second. The reason why I want to figure out the invariant points is because it's going to help us with graphing this beautiful reciprocal function. Okay? And remember what the invariant points are. The invariant points happen at plus and -1 when y equals to plus or -1. So basically it looks like it's going to be here and here. This is, of course, y equaling to 1. This, of course, is y equaling to -1. But I want to be accurate. I want to know what those actual values are. So go back to the original one, which is negative 1/2 x plus 4, negative 1/2 x plus 4. Let that equal to positive 1. Solve it. So subtract 4 from both sides. Subtract 4. You got negative 1/2 x equaling to, looks like -3. Multiply it by -2, multiply it by -2, x equals to, in fact, positive 6, because a minus times a minus gives you a positive. So look at this, 1, 2, 3, 4, 5, 6. Oh my goodness, right bang on 1. Boy, this is a pretty accurate graph. Now, let's find the other one. This is going to be negative 1/2 x plus 4 at -1. So again, I'll use a different color. Subtract the 4, and look what you get. You get a -1/2 x. Looks like this is about -5. Multiply both sides by -2, you got x equals to positive 10. So we know that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. There's our other invariant point. That is going to be the point where this graph is going to deflect upwards. So what do I mean by that? Remember how we had a graph that did this? And I said, okay, there is your asymptote. And because it's got a section in here, there's where your graph has to be. Because it's got a section in here, there's where your graph is going to be. But look at this. This has a section which is right here. right here. Look at that. So that must mean, look at this. There's your invariant point. We're going to start from here, going like this, through the invariant point, and go upwards like that. Excellent. Same thing goes with this. There's the section of the graph, which is down in this section down here. We're looking at this piece. And there's our invariant point. So that means it's going to come from this angle here and then come right out here. And again, not touch your horizontal asymptote. I should say your vertical asymptote. This guy ends up being your horizontal asymptote here. And your horizontal asymptote, of course, is going to be y equals to 0. So kind of a neat question now, and kind of flip-flopping. That's what we want to look at. We want to look at as many different variations of this as possible to really get a good handle on.